All right, let's go over your day one assignment on just graphing some quantitative data, the new ways that you did, dot plot, stem and leaf plot, and histograms. Okay? All right, so on this first one, we've got all the data. Oh, you know what I didn't do? I didn't label. And so, poo, I see that missing. All right, so here we have the data from 0 to 12. And what I need to make sure that I type in there is the label, which would have been here. And I think this problem is the time to eat breakfast. Okay, breakfast. And it was in minutes. Okay, so there you go. That emphasizes that you have got to have that. You've got to have that label in there. All right, and then we just put a dot for each one of these pieces of data that fell on those amounts. So notice that we really can tell what each of the individual pieces of data are from this dot plot. Okay, and that happens most of the time with dot plots. All right. So this question asks you to do a couple of things. First, it wanted you to round the data to the tens place. So that's why I gave you a table that had a little bit more room. So I went in there 630, 670, and I rounded all of them, hopefully correctly when I was doing this, to the tens place. Okay? If I had a little mistake, then I'm sorry. And then it asks you to make two different stem and leaf plots. One of them without a split stem. So over here I have 6, 7, 8, and 9. So I did not split the stem. But splitting the stem makes it such as this: 6, 6, 7, 7, 8, 8, 9, 9. Okay? So then I went and I started to put my things in order. So for example, in the 600s, I have 630, 670, 650. So I had to kind of look all together. I had 600 was the first one, 630 was the next one, and then 650, and then there's another 650, and then 670. So I had to make sure that I did the leaves in order from least to greatest. All right. Which then it was easier to do this split stem after I already had this first one done. Okay. Because you know that this stem here is going to represent the 600 to the 640s, up to 650. And then the second one is going to represent the 650s up to 690, because once you get into the next group, that's the 700s. Okay, so you have got those. So if I split the stem, then 0 and 3 would be in the first 6 group, 5, 5, 7 would be in the next group. All right, and so on. So I did all of that data. And then, of course, you have to make a key. And this is very important, see, in this case, because an 8 and a 1 means 810 millimeters of rainfall, not 81, not 8.1. So that's why key is so important. I think we're also asked, which one do you prefer? No, I guess it doesn't ask which one you prefer. I preferred making the split one because I already had the other one, and then that made the split one easier. But anyway, so there you go. All right, next. So we kind of went over this a little bit in class, but if I didn't get to go over this with you, if you were on remote, then let's take a look at what happened, because we had a ton of data here. So the first thing that you should do is find the spread of your data. Okay, and so I found the range. I took over here on the left the highest minus the lowest, and I found that that's a spread of 15.4. Okay, and so then I'm going to decide, I'm going to make 5 to 10 bins. So I'm going to divide this 15.4 by 5, 6, 7, 8, 9, or 10. I'm going to do that. Because 5 goes into that evenly, I decided to divide by 5. All right, if 6 went into the number evenly, I probably divide by 6 and so on. So I'm going to make 5 to 10 bins. So I decide to divide by 5 because that was the easiest that went into 15.4. This tells me to make the x-axis bins about 3 wide. So this is 3 minutes wide because here I labeled it. This is the average travel time to work. 15, 18. So looky here, I did my little tick marks because I jumped from 0 to 15. You can do that on the x-axis, but you cannot do that on the y-axis. If you do that on the y-axis, we've seen time and time again how that violates the area principle. Okay, so there's my times. And then this is a ton of data. So what I did was I came down here and I kind of made myself a frequency table. I was like, okay, let me go count the ones that are in the bin from 15 up to 18, not including 18. And then I came here and I did them in a certain color because I tried to just count them by looking at it and it became too difficult. So I marked them by what category they fell into. And here's the frequencies, hopefully they are correct, that I decided that I had. So it was based on the fact that these are kind of going from 2 to 16. That is why I decided to make these numbers on the y-axis go by 2s. I did from 2 up to 20. And I labeled, this is the number of states. Okay? All right. Then, so I guess the third step then is to tally the frequencies. Tally, EY or Y, tally the frequencies. And then 4, you can, then make your y-axis and then graph it. Okay? And graph. All right. So you can see that with large data sets, there's really quite a bit more involved in making a histogram than the really simple one that was in the notes. So sorry about that. All right. Number 4, G ended up being the right one there. Next, number 5. So what I did was I just started looking at one of these stems sections. So I looked at the ones here. I looked at the dots to see which one came out to be correct. B ended up being the one with the correct leaves. Find the minimum and the maximum, and then I counted how many pieces of data there were so I could find the median. The median ended up being in between 32 and 34, so that's why I knew the median was 33, so here it ended up being that answer choice B. Let's see. And then so next, this table shows 20 scores and they ask you. So again, I just looked at the 7s, which ones were correct. There were 10 of them in the 80s and 3 of them in the 90s. And here, the frequency that was displayed. So notice they messed up I marked what they messed up on each of the other choices. Look like the x-axis. Okay. And is that it? I think so. Okay, so hopefully that helps you on that first assignment on displaying quantitative data.